Welcome to this video how you can use HTTP with Flowable. In this video, I'm going to explain you how you can use the Service Registry together with Flowable. Now, to get started, let's look first at our REST API. I prepared a really simple API, which is listening on localhost 3000 and returns us here a list of data items, name, laptop, description, PC, which you can carry with you, and so on. Now, what I can do is I can query here just one single item by providing the ID in the URL. So now I just received the laptop back, or I can go ahead and say I would like to create a new item. Therefore, I use post and the URL without the ID. I provide then a body, which is from the type JSON, and that contains here my name, which is, for example, a mouse, and then the description as well, a small animal. There we go. Once we send that, we get that information back, which we sent, as well as the ID. When we now go back and say we would like to get all items, we are going to see that we have those two items. Now let's go into Flowable and try to fetch all the items there and later on also create a new item. Therefore, I'm going ahead and saying I'm creating a new app. That's now my REST example, which is basically the app which I'm using in here. The palette type is work, since we would like to use the service registry, and then we just say create. Now, once I created that one, I can say here I would like to create a process, and this one is fetch all items. It's my first process in which I'm going ahead and just receiving all items. I'm adding here now a first task, and that is Flowable work, and in there the service registry task. So that's basically fetching all items. And in here, I'm going ahead, and you see it already marked in red over here, select my service model. That's my item service. So I can quickly just create a new service here, press the create button and open that model for editing as well, which now gives me the possibility to create a service. The service type here is REST, and then we can configure our REST server. Therefore, I say here that we would like to have a base URL. Now, normally you would go ahead and describe that base URL in your properties or make it dependent on the environment. However, for me now here in a single environment, I just go for my local endpoint. Since my Flowable is running in a Docker, but the REST endpoint is running outside, I use this Docker specific host name in here, which is calling out of my Docker environment to my local host. In case you have any authorization, you can go ahead and specify that here as well. Now, request and response handlers are either expressions or scripts which are executed when you are creating the request or getting the response to manipulate that before you give it to your process or case. We can also have a shared output mapping. We will look at what the output mapping is just in a few seconds. And with the shared output mapping, you can share that between different operations. Now let's add the first operation. The first operation is fetch all items. That one is from the type search, since it's returning multiple responses. Then we can specify here the URL. The URL here is based on our base URL, which we have specified before. So we only need to provide /items in here. That's get. We can override the authorization. We could specify any input parameters in case we would need some, but we only need the output parameter in here, which is going to be data. Data is from the type JSON, so that's a list of multiple elements, and with that we can go ahead and finish that and save our service. Now our service is ready to use, and we can configure here for the service model also the operation. Therefore, you need to go to detail in here, and there you can select your newly created operation in here and say this output parameter we would like to map to items, for example. Now let's say finish in here, and then we are saying we are creating here a new user task, and that user task in here actually we make multi-instance, since we would like to receive for all the items just one user task. So I use the collection items in here, and then I provide the item. I just call that item.name. You obviously could here create a form as well, and with that show more information. But the main point for this video is to show you the service registry and not the multi-instance. So I will rather keep that simple. Now in the background I saved and published, and once we execute that now, we see actually that we have here two items, item laptop and item mouse. So for each of them we created a task. Let's make that a little bit more interesting by creating a new process. And this time we also would like to get input information and send that to our service, for example, as a URL parameter. So let's say we have a process get item. That process in here has a simple start form, item ID form. In here I am going to say I just provide a really simple text field. Actually, no, it's not a text field, it's a number field. So let me just quickly take the number field in here, my ID. That's a number field, since that's the ID which we are providing. And then in here we can say as a next step, we are using the service registry task, fetch by ID. And then we are displaying it probably afterwards and ending our process. Now service model, we can reuse here the exact same service model, and therefore we can just link it to an existing one and select our service in here. We need to open that one for editing again, and then we can add a second operation in here. That's a second operation just called get item, has here then a lookup, since it's just for a simple single one. And we now specify here items, since that we would fetch, followed by the ID. Now to provide an ID in here, we need to add an input parameter. Then I'm just saying I add a new one, which is from the type long, and that one here is actually required. That's our parameter. Now everything what you have here inside the ID, and we could actually take that ID as a name in here and then provide it here as a URL. So in here we can now use a backend expression and access those input parameters, but only the input parameters, not the parameters which are part of your process. So you always need to have a proper in mapping. The output here itself, basically you can create as well. There we would like to have name as an output parameter, which is from the type string. And then we have also the output parameter description, which we would like to see in here. And with that, we have configured what we are going to receive back. Now let's save that, and then we can go to our process. And in the process, we can go ahead and configure the fetch by ID, where we say here now get item. We have the input parameter my ID, and we have the output parameters actually, which is going to be my name and my description. And we finish that, and we say here now item colon my name, since that is what we are going to see then later on. Let's save that, publish that, and then we are going to Flowable work and say in here, I would like to get an item by ID. So let's say item 2. And we see then here we have the task item mouse. Now, one interesting thing which I didn't mention so far, when you are in a test environment, you have Flowable Inspect. And here you can actually select Service Registry, where we can look at basically the information which we sent to that server and the response which came back. So you receive also the headers and everything what you haven't mapped in here. So you see, in addition to the name and description, we are also getting back the information about the ID. Now, not all REST requests are successful. For example, when we go ahead and say we are executing now the get item with the ID number 4 and submit that, then we receive an empty item name in here. We can actually, when we go back to the process, then select again the service registry and we see in here that we got back a status code 404 with those headers and an empty body. That's the reason why we also did not map something. Now, to solve that or to make the behavior a little bit nicer, we can use so-called error boundary events together with handling the error code. Therefore, you need to go back to your service mapping, and here you have handle status codes and fail status codes. In those lists, you can represent basically the error codes which you would like to handle. For example, a 404 we would like to handle, but probably also other client or request related status codes. So often I just go ahead and say here 4xx, which is handling all 400 codes. And with that, I can now use an error boundary event. So that's the one over here. Map it to the specific task and then say error occurred. Now, in addition to that, you can also on your service registry bind additional parameters to that, but you have seen for us we received an empty body, so that's not that interesting. And we are going to save that and publish that. And we now see when we execute that again for our ID number 4, that instead of seeing the item, we are now seeing the error occurred, which then goes here also to that specific task. We see here, as earlier, still the error message and all related to that REST request in here in Flowable Inspect. There are also technical errors which you probably won't handle inside your process, and I prepared a special ID actually for that. So when we are going for the ID 42 and submit that, then we are not going into that. We see basically the error occurred was not handled in here. And when we look at, and I need to go back to my process, our service registry request, we see that the status code for this one was 500 and the message was internal server error. Now I could map that to my boundary event as well, but 500 or something similar often also means that something went completely wrong and you rather would like to retry it. And with that, you can say that you would like to fail for those status codes. So here we can enter 5xx, and with that, we are rolling back our transaction to the last time when we actually went ahead and saved the transaction. Now, for me, that would mean the process would never have been created. Rather than doing that, we can also go ahead and say here that we are making this asynchron, and asynchron actually means that we are persisting before the task and then executing everything afterwards in a separate transaction. When I save that and publish that again, then we see in here, when I execute it now the next time for my ID 42, that rather than just moving forward, we see here actually that one exception occurred, and it now created a job for us. That job is automatically retried, and you can see those jobs in Flowable control, for example, when you go to processes jobs. In case the job is case related, then you would need to go to cases jobs, and there you will find that job as depending on the time, first a timer job. Since it's retried a few times, it's creating a timer job, which is then moved to the executable jobs, but you need to be lucky to see it there since it fails quickly. And then eventually it will end up in the dead letter jobs, since in here, that's the place where it then stays until either somebody solved the issues and re-triggered it, or somebody figured out basically that we need to do something else with it. Now, I could move that job. That would make sense when somebody would have fixed my server. I did not fix the server, so I'm not gonna do that now. With that, we talked about error handling, and we can continue now with other operations. So a logical next step is actually to just create a new item. So let's say we have a process, we call that create item. And in here, we would like to, similar than before, go ahead and create a new item. Therefore, we need to have a form to provide the data, item data, which is, for example, in here then my name and my description. Probably item name and item description would be better, but let's not talk about naming. And we can now say here as a next step, we would like to have a service registry task, create item. In here we provide the service model, which we already have. And we are opening it since we don't have the create operation yet. And we can say here now we would like to have a create item that's from the type create. The REST configuration goes against /items. We would like to have a post, since that's what our REST API expects. We can provide as input the one name, which is a string, and the output is the description, which is also a string. Now, would we have created the operation before with shared output parameters, we wouldn't need to do anything in here. But since I didn't do that, we need to configure here the ID as a long, and then also the name as well, that's a string, and the description we can provide here as well as an item, which is coming back. Obviously, name and description are not that exciting since we already have them in here. So let's add that operation, and then we can go back to our create item process, select that operation in here, and say we would like to create that item. We could do the error handling as we are used to, and then here we say my name and my description, and we are going to say this ID is stored in my ID, and I just add an end event afterwards. Now let's save that and publish that, and let's say we create a new work item. That's now a create item. I select, say, keyboard here, music instrument, and let's submit that. And with that, we have now created a new item. We actually see here also that this myID3 came back. And when we look at the service registry in here, we see that we received an 201, and that information here basically came back from our REST service. Just for completeness, I execute now our fetch all items process again, where I see that now I have all the 3 items coming back from that REST endpoint. With that, you have seen how to use the service registry to actually execute REST requests. There are 3 different possibilities in total to execute them. Service registries are just one of them. You can also use an HTTP task or data objects to do that.